In this question, we're being asked to calculate the reading on the voltmeter in the circuit. Now, the voltmeter in this particular case here is in between these resistors. And what we're being asked to work out then is the potential difference between that point and that point. And to do this, we need to create a bit of work. So let's have a wee look at how we solve this one. First of all, let's label the resistors. We're going to call this one R1, R2, R3 and R4. So what we know is R1 is 6 ohms, R2 6 ohms, R3 is 4 ohms, and R4 is 2 ohms. We also know the supply voltage is 12 volts. Now, by convention, when you've got a voltage of 12 volts and you've got a positive and negative, the 0 volts is considered to be the negative, and the plus 12 volts is the plus. So if this is 0 volts here, then that's all 0 volts. So at that point, it's 0 volts. Similarly, here it's also 0 volts. By a similar argument, if that's 12 volts here, then it must be 12 volts here. And it's 12 volts here. So what we are required to do is find the potential difference across here, and that will tell us the potential at that point. And we'll do the same for this later. We'll do one at a time. So let's do this branch, which is two resistors in series, a voltage divider circuit. So voltage across the first resistor, V1, is equal to R1 over R1 plus R2 multiplied by the supply voltage. So V1 becomes 6 divided by 6 plus 6 multiplied with a supply of 12. So that works out, and you can use your calculator to prove it, but I think we can convince you 6 divided by 12 multiplied by 12, that cancels with that to leave V1 is 6 volts. So that, if you like, is the potential at that point there. That's 6 volts there. And now we need to work out what the potential is at that point there. Similar argument as we had previously, except we're working out the resistance across this third resistor. So we're going to call that V3. So that equals R3 over R3 plus R4 multiplied by the supply voltage. So V3 equals 4 divided by 4 plus 2 multiplied with the supply voltage, which is 12 volts. So V3 therefore is 4 over 6 times 12. That cancels with that to turn into 2. So V3 equals 4 times 2, which is 8 volts. So at that point is 8 volts. Now this voltmeter is measuring the potential difference, PD, between 2 points. And it's simply 8 subtract the 6. That's 8 taken with 6. The difference between the two is 2 volts. Sorry about the wee bit of mess here, but there you go. That's how it works in the real world. Hope that helps. Quite a complex question.